Okay, good afternoon. We will begin with this problem on the topic of work, energy, and power. I think let's go on to question one for us to be able to solve this problem and see if we can understand what's going on. Okay, let me copy this. Copy. Let's go paste it to a new page. Okay, let me make it smaller. Okay, so the question says a man uses a rope to pull on a box on a frictionless surface through a distance of 8 meters. If the angle that the rope makes with the horizontal is 30 degrees and the force exerted on the rope is 60 newtons, draw, okay, this is the first question. It says draw the free body diagram of all the forces acting on the box. Calculate the work done on the box by the force applied by the man. And the last question is, does the gravitational force do work in this case? And explain your answer. Okay, so let's first draw the scenario, what is going on. They say here we have a box. Let me try that again. We have a box. This box rests on a frictionless surface. Okay. They're saying this box is pulled. Okay, let me move everything to the bottom. Okay, let's put it here. They're saying this box is pulled by a force of, let me go back to my pen. They're saying this box is pulled by a force, by a rope that has a force exerted, and it makes 30 degrees to the horizontal. Let me use my eraser here to signify the force. They're saying the force is 60 newtons. 60 newtons. We're not given the mass of the box. Okay, so the first question says 1.1. It says we should draw the free body diagram. So what I usually like to do when I draw the free body diagram is that I first draw the box like this. And then with my box, I just label all the forces that I know are acting on this block. Okay, I know that if this box is resting on the floor, then definitely it should have its weight, which is Fg. The box should also have a normal force, which is N. And this box is being pulled by a force F, which is our force applied. You can separate this force into its components, which would be Fx and Fy, but usually you don't get 2 marks because you've separated the two forces. Just leave it as it is, because the marks usually come from these forces on its own, and it's just 1 mark per force, so just leave it as Fa. But this is not the free body diagram. If you want to represent this with the free body diagram, remember this you have to actually say it's your normal force. This is the gravitational force. Gravitational force. And this is your applied force. Okay, so when you have drawn your box and easily identified all your forces, then you just replace your box with the dots and then replicate all these forces that you've already drawn. So you have your normal force, you have your Fg, and you have your Fa. You see, like this now, you have your 3 marks. Okay, let's move over to the second one. So the second question says, calculate the work done on the box by the force applied by the man. Okay, so we remember that the equation for the work done is work is equal to the force times the displacement cos theta. This theta is the angle of the force relative to the motion of the block, of the box, which is basically the angle between the applied force and the displacement. Okay, and in this case, we know that the force is acting 30 degrees to the horizontal. So our force is 60 newtons times, we are given that the distance is 8 meters, or the displacement that this box travels is 8 meters, if we say this was 0 meters. So it's 8 times cos 30 degrees, which is one of our special angles. And then when you're here, you can just go over to your calculator. Let's go to the calculator. And, I've already done the sum here. So 60 times 8 times cos 30 equals 415.7. If we go back, it's 415.7 joules, because the units of work done is the same as energy, which is measured in joules. So that's the amount of work done by this force in moving this box from this 0 mark to the 8 meter mark. Okay. Then the third question says, does the gravitational force do work in this case? So as we know, work done according to physics is only calculated, or we say that work is done in moving an object if the object actually moves. So if the distance is not if the object is not moved, regardless of how much force you've applied. So because the formula for work done is the distance multiplied by the force. So if this is 0, ultimately your work done will always be 0, no matter how big this number is for the force. So in that case, we know that we need our movement, or the distance, to be greater than 0 for work to be done. So when we go back to this object, we know that this object is only moving horizontally, meaning it can either go to the left or to the right, But in this case, we know that it's going to the right, and there is no up or down movement, up or down, meaning since there is no movement or distance traveled by the box in the y-axis, then it means gravitational force does not do work on the box. Okay, so I guess that comes to the end of this question, and I hope my explanation was clear enough for you to understand. Thank you.